18. This wants us to expand as a sum of individual logarithms, each of whose argument is linear. So that means we don't want any exponents besides 1. We want it linear. Okay, so it starts out like this, and then hopefully we all know that we can rewrite this fourth root as just to the 1/4 power. So that's the first thing I did. And then I'm going to use the law of exponents that says, you know, I'm going to multiply the 1/4 times 2. That gives me a half. And then the 1/4 times 3, that gives me 3/4. I left the denominator alone. And then I used a couple different log laws. I know there's more than one way to do this. I think I did this with Seth in class. He took the x and brought it up here as x to the -1, and he also brought this up here as y plus 2 to the -1, and you'll get the same answer if you do it that way, or you can do it this way that I did it. I think of the top part as like a multiplication. You know how like you can write a product as a sum? So I wrote these two top ones as a sum because they're being multiplied, right? See, I just grabbed them, separated them out using the log law. And then remember, when you have a quotient, you can write it as a difference. So it's kind of like you're distributing that difference though. So you just write. So basically the ones in the denominator get a minus sign, because it's that log law that says if you have a quotient, then you write it as a difference. Okay, and so that'll give you the same answer as if you would have popped these two up onto the numerator, and they would have had the negative exponents and you'd have the same exact outcome. Okay, and then you just use that one log law that says you can bring the exponents out front. So just bring each of these exponents out front. Okay, and there it is.